Hello, and welcome to our virtual Lunch and Learn. I'm sorry that we've been
Hello,
delayed.
can you all hear
We've
me
had
okay?
technical difficulties. Today we're talking about Ross Control's fluid power basics. My name is Leanne Ireland, and I'm the Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today are Ross Control's Chris Brogli, Vice President of Global Safety Business Development, and Eric Cummings, the America's Safety Business Development Manager. Ready to answer your questions in the comments today is Gerald Clark, Systems Engineer with McNaughton-McKay. Feel free to enter your questions in the comments as we go along, and we'll have a Q&A portion at the end for Chris and Eric to answer those in more depth. We'll be getting started shortly, but we like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. You can view recordings of previous virtual Lunch and Learns in our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn, Ross Control's Fluid Power Basics. Let us know where you're joining from in the comments. Feel free to type any questions as you have them in the comments while our presenter, Chris Brogli from Ross Controls, talks us through the fluid power safety development process. Our specialist, Gerald Clark, is available to chat with you in the comments section, and Chris will be available to answer your questions during the Q&A segment at the end of the presentation. If you'd like to reach out afterward, or if you have any further questions, you can send us an email at mcmclive@mc-mc.com. Be sure to let us know which session you attended. We'll have that email address on the screen for you at the end as well. It looks like we have quite a few attendees. Because we're having technical difficulties, I'm going to pass this over to Chris, so be patient while he comes on.
Okay, can everyone hear me okay? Because I can't hear anyone. I don't know what's going on. Hello, everyone. This is Chris Brogli from Ross Controls. Today, we're going to talk about fluid power safety development process, and I'm going to introduce you to the 6-step process that Ross published in our Machine Safety Guidebook earlier this year. And as you know, McNaughton-McKay is one of our distributors in the Michigan area and Northern Ohio area, and soon to come, Southeastern U.S. area. And so we have kind of partnered to present this presentation. And just a little on my background, I'm a TUV functional safety expert. I sit on quite a few ANSI standards and also ISO standards. And I'm going to be your main presenter today. So with that said, we're just go ahead and get started. What I'm going to do is introduce you to the 6-step process, talk about some of the legal requirements for safety, talk about risk assessment requirements, and then talk specifically about fluid power risk assessment requirements, because most people are either not assessing fluid power or they're assessing it incorrectly. And since risk assessment is the start of the safety design process, if we assess it wrong, we probably designed our system wrong. So once we get through the assessment, we're going to talk just briefly about functional specification development, different risk reduction methods, what those risk reduction standards are, and then talk about the different measures for reducing risk, and then getting into a little bit of what we call fluid or safety system design, and ultimately verification validation, and then have a few closing comments. So with that said, this is the Ross six-step safety development process that is highlighted in our machine safety guidebook. And step one is the risk assessment. And as you guys may well know, risk assessment, we're supposed to develop a risk assessment plan before we start. We're supposed to assess all attributes of the machine, including fluid power. We're supposed to look at all modes of operation as we're doing that assessment in order to determine the required system performance. Once we have done the risk assessment, we then need to determine how we are going to reduce risk for each of the hazards that were identified. And so we do this by looking at the different job tasks and type of job tasks there are, and what the functionality needs are for each of those job tasks for each mode of operation of the machine. Then we're going to determine what our best mitigation techniques are, and then determine the required safety functions. These will lead us right into selection of mitigation or risk reduction devices, and then ultimately will drive our design. And whatever's identified in the functional spec is what we're going to validate in the installation and validation process to prove that the system operates as we functionally specified. And then once we have done that, put the system into use, the standards require that we do periodic maintenance and testing. And so we're going to touch on each of those steps kind of through the next 30 to 40 minutes. And so with that said, we will be referring to the Fluid Power Machinery Safety Guidebook that's on the right-hand side of the page there as we go through this process. And what we're going to be looking at is what are the legal requirements. And of course, here in the United States, OSHA sets those legal requirements through CFR 29, which is basically the Code of Federal Regulations. And then Part 1910 specifically sets the machine safety requirements. And then in Europe, and the reason I'm mentioning Europe is because there is harmonization of standards. So a lot of the global standards look just like and have the same content as many of the US standards. So in Europe, they have this thing called the Machinery Directive, and it sets out those legal requirements. And then if you look below there, there's a hierarchy of standards. And what I mean by that is if you look at that second level, ISO 12100 and its equivalent here in the US, ANSI B11.0, basically outline the methods and steps for risk assessment and risk reduction. And then below each of those, there are different what I call risk reduction standards. And in Europe, it's ANSI Z244, which outlines the requirements for risk assessment. Well, in Europe, it's called ISO 14118. Very similar requirements. When you lay these standards side by side, probably 90% of the content's the same. And then when you get into what we call machine safeguarding standards, where we're actually designing machine solutions, in the US, we have B1119, which talks about the performance requirements. Well, it actually references the ISO standards on the left and IEC standards, the ISO 13849 and IEC 62061. So what I'm getting at, there's a lot of cross-referencing going on. And the problem is, if you look at the fourth level down here, this is where pneumatic and hydraulic safety are. And the problem is, most people don't even know that there is a pneumatic safety standard and a hydraulic safety standard. And those are called ISO 4414 and ISO 4413. They were adopted by the National Fluid Power Association here in the US. And when anything is a national standard or a nationally recognized set of documents, it now becomes law. So that means that we need to understand the principles of ISO 4414 and 13. And then when we get into electrical safety, this gets more into design of the electrical circuitry inside, wire colors, stuff like that. But it also identifies stop categories. That's in an FPA 79 and its European equivalent, IEC 6204. So just keep in mind, laws just at the top, OSHA and the Machinery Directive, they just define the requirements. They don't tell you how to do anything. That's what the standards are for. And this is not going to be a big standards lecture. This is probably the only slide you're going to see really on standards. And the rest of it is going to be more application. How do we do it? And so if we look at ISO 12100 and ANSI B11.0, both of them deal with risk assessment and risk reduction. The top part of the flow chart shown here above show that that portion is risk assessment. Those two standards really outline the requirements for risk assessment, how you prepare for it, how you document it, what you do with it. And then the bottom half of those two standards deal with risk reduction. So we're going to jump right into step one in the 6-step process, which is risk assessment. And what we need to do when we do the risk assessment, we should look at all sources of hazardous energy in every mode of operation. And the reason I mention that, most people that are doing risk assessments spend most of their time around automatic operations. Well, here's where the problem comes in. A recent OSHA study, and I've got a typo there in the orange at the bottom, a recent OSHA study showed that 60 to 70% of all injuries happen outside of automatic or normal operations. It happens when we're doing maintenance or setup or changeovers or adjustments, maybe removing a jam from a machine. And so most people, if they're doing just automatic and normal operations, are ignoring the biggest part of the potential injuries. So we need to look at all those other modes like maintenance mode, setup mode, changeover, what we might call threading of the machine, feeding materials into the machine, even quality interactions where they're taking measurements on something that's in process. And so we need to look at all modes. And then in our assessment, we need to look at things like electrical, but also pneumatic. And as part of our risk assessment, we also need to identify what could be addressed with lockout tagout, because maintenance activities should be done with lockout tagout. So we need to look at this holistically for all modes of operation. And this holistic approach has changed how many of the best-in-class companies are assessing and addressing risk. So many of the consultants that I'm working with and multinational companies have gone in and implemented a 3-step assessment process. Step one is identifying the task type. So what is maintenance, which would be treated with energy isolation or lockout? And the reason people do that is, why would you need to do a performance level calculation if it's going to be treated with lockout? So that's something you can separate as your maintenance activities. Then when you get into machine safety and what I would call task-based isolation, this is where you really get into the risk assessment piece. And most companies are doing some sort of using some sort of risk estimation tool, like this basic risk estimation tool from ISO 13849 is shown in the middle. And they're just looking at severity and frequency and possibility of avoidance. But they're not really looking at fluid power. If we're going to assess fluid power, we have to do pressure and force analysis. And this is a step many people are missing. So a lot of companies are starting to use a 3-step assessment process, like I'm showing here, to evaluate the machine holistically. So with that, I'm going to take a look at this and understand why companies are starting to look at fluid power. There's a statement here from ISO 13849, and there's a similar statement in ANSI that says pneumatics and hydraulics are part of the safety related part of the control system. That means they need to be considered. It also says that it requires products that are proven in use or well tried. Well, the way Ross proves that our product is well tried and meets safety requirements is we do a third-party certification. Most of your company, reputable safety companies are doing third-party certification. So you may hear terms like TUV. I know Rockwell, who is also one of Mac and Mac's main product lines, uses TUV certification to prove their compliance. We use DGUV, which is just another certification body, to prove that. So a lot of regions of the world will not allow non-third party certified product. That's why we do certifications. And so now that we understand that pneumatics and hydraulics have to be considered, we have to think about assessing it. And that's where we need to understand the pneumatic and hydraulic safety standards. And here's a scary thing. If you look, ISO 4414 for pneumatics was published in 2010. It's been around for 10, 11 years. Most people don't know about it. There's also a hydraulic safety standard that was published in 2011. It's been out for 10 years. Most people don't know it. And here's what those two standards say. They say that all intended operations and use of the system shall be considered. A risk assessment shall be carried out to determine foreseeable risk. Any risk identified shall be eliminated. And then if you look all the way at the bottom, the control system shall be designed in accordance with the risk assessment in order to meet ISO 13849. So they're even showing you what design standard there is. And so with that said, we
I'm working to get him back on, everyone. Please hold tight. I'm so sorry for the confusion. Well, hi, everyone. It seems like we've lost Chris, and I am not sure. Oh, He's trying to come back in, and we are working. I'm so sorry about all this. Chris, can you hear me now? Well, you guys, I'm not really sure that we're going to be able to continue today. I think maybe what we'll do is we will, if you are interested, if you can email us at MC Live, that's Mac Live at mc-mc.com. I'm going to put that here in the comments. And then we will go ahead and send you the presentation. And if you're interested, we'll try and schedule some time with Chris to see if we can get you some training. It would also be helpful when you send us an email if you tell us where you're located, so that we can get with your account manager and we'll see what we can do. Again, I apologize for all the technical difficulties. If you've been with us before, this is a first for all of us. So I guess this is the beauty of live. So again, please reach out to us at maclive@mc-mc.com, and we will get you the presentation and we will follow up with your account managers. I am so sorry, and I hope you have a great day. Thanks.
Okay.